All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, depending where in the TOC world we find you today. This is Carol Patak, and I'm the General Manager for TOC ICL, and I welcome you to our latest series of webinars. We're so delighted to have our webinar presenter back with us today in her 0 to 60 webinar series. This has been an absolutely phenomenal series for those wanting to learn the fundamentals or the basics of TOC. Even for those of us that have been in TOC a long time, I know I enjoy listening to these basic seminars. One thing I did want to call your attention to is the conference coming up in June 2013. I know you might be thinking that, wow, that's quite a distance away. But one of the things we've added to the 2013 conference is a basics track, is being able to reach out to folks that are new to TOC and do some basics education as part of the conference. So we're very excited about that. That'll go on for a day and a half, and the conference is in Germany. This is going to be a location not to miss. It's in Bad Nauheim, Germany, and that is a spa town in Germany, and it's just an incredible place. For those of you that are history buffs, you'll recognize the town is where Elvis Presley was assigned when he was in Europe during the Army, during his Army days. So it's quite an interesting place to walk around, and the little village is about a 2-minute walk from where we are at the Dolce Hotel. If you are thinking about coming, it is not too early to go ahead and register. You don't have to pay in full yet. You can just put a deposit down and hold your room. We have taken the entire hotel facility again, just like we did in 2011, so it'll be just TOC ICL. What an incredible place to then network with people and have some after-hours discussions, and the bar that is right on site there, as well as some incredible grounds. So look at the website, go ahead and get registered. Also, too, I wanted to bring your attention that the call for presentations is open. If you have a new idea and you want to share it with the community or discuss it, we've got a format that we tried out last year, and it worked out pretty well, so we're going to bring it back again this year, called a Hyde Park session, where you get to speak for 5 to 7 minutes, like somebody would crawl up on the soapbox in Hyde Park in London, and then the debate can begin. So those sessions are scheduled for 30 minutes with a 5-minute presentation. The standard presentation formats are a 30-minute presentation slot again. We found that worked really well last year. It caused the presenters to have to really get down to the essence of what they're saying, and the attendees just loved being able to see a higher variety. If you didn't see conference last year, you weren't there, you can purchase either the online access to the recordings, or you can purchase the DVDs, and those are on sale right now on the website. If you are interested, there's also a lower resolution recording that's available on a USB drive, so that you can carry the entire conference in the single USB drive and listen to it anytime that you want on your pad or your computer. So check out the TOC ICL website. I think you're going to find some of the changes that we've made there quite good, things a bit easier to find, and we're constantly adding new content. Lisa's next session is going to be on December 15th, and that will be on distribution. We also have a series going on with Ellie Schregenheim right now, and we're also very excited that Helena Federico is going to be coming in January and talking about how to challenge the assumptions behind the cloud. I don't know about you, sometimes when you work with clouds and you somehow come up with the same answer that you thought you had, you really haven't reached deep enough to challenge those assumptions. So Helena's going to be coming in and doing something on her new book. So with that, I'm not going to take up any more of our time this morning. I want to introduce our presenter today. Lisa Ferguson is the founder and CEO of Illuminatopia. Illuminatopia is an organization that focuses on illuminating the way to utopia for individuals, organizations, and society. After Lisa earned her PhD, and she's also an MBA, she taught operations management full-time at a university business school for 10 years, and she's been teaching TOC for over 15. Dr. Ferguson is the author of the chapter on strategy and tactic trees in the TOC handbook. She's also planning to publish in 2013 her book on teaching how to write and utilize transformational strategy and tactics trees to enable an organization to successfully achieve its goal. Until 2008, Dr. Ferguson spent a year working one-on-one with Dr. Eliyahu Goldratt, the founder of TOC, as his apprentice in order to learn from him how to write and further develop her expertise in TOC. She's got a new exciting book called My Year with Dr. Eli Goldratt, and it'll be published within the next few months. Dr. Ferguson has been involved with the TOC International Certification Organization since its inception, and it's been our pleasure to work with her closely as she's worked so hard for our certification program. She was a board member from 2008 to 2011. She's certified in supply chain logistics, project management, and the thinking processes. So with that, Lisa, I'll turn it over to you.
Thank you, Carol. So today's is the second webinar in the series of 0 to 60, Intro to Project Management. Project management was actually the second application that Ellie Goldratt developed for TOC. For a number of years, TOC was just focused on how to improve production. And then Ellie was approached by a company that was very good at managing projects, but was not getting great results. Excuse me. So they asked him, they thought, since he had come up with a solution for production, that he might have the potential to come up with a solution for how to better manage projects. And that's what we're going to talk about today, is that solution. In TOC, we've only focused on developing what was needed to be successful in managing business, or actually in how to be more effective in thinking. But in the area of business, is if there are applications that are already working there, we don't change them. We just focus on what is not working and improving that. So what are the typical project results? We see that most projects are either late, over budget, and/or compromising the scope or content in terms of quality, or not doing all that they plan to do in the project. So it's not uncommon to see projects be very late, be very much over budget, be sacrificing the quality. We've heard so many stories about this, airports that have opened late, many different projects that are late. So what do we need to do in order to more effectively manage our projects? Well, first, what we need to do is follow the processes of TOC, is to apply, as I discussed in my last webinar, the two key concepts of TOC, which are the thinking processes, looking at what the core conflict is that's leading to all the undesirable effects, and apply the 5 focusing steps to what the constraint is, the factor that is most limiting the organization from achieving more of its goal, or the system that's being studied. So let's begin by looking at what the typical complaints are in projects. Our project lead times are too long. Project return on investment and cash flow are frequently jeopardized. Due dates, budget, quality, and/or scope are frequently compromised. There is a constant battle to reduce safety time. We sometimes miss dependencies in the project plan. So miss a step that needs to be done before another one and have to go back and fix things. Deliverables are not always clear, and critical resources are losing a lot of time moving from one task to another and having to report progress on all tasks. Do projects fail because of uncertainty in content, skills, processes, etc.? I mean, there's a lot of variability there. We don't know exactly how long it's going to take us to do each task in a project and to complete the project. Or is failure due to the common practices for managing projects? That's what we're going to address today, is that there is an erroneous belief that is causing us to not manage projects well. And that is, in order to finish the project on time, we must finish each task on time. This is actually not accurate. Given the high level of uncertainty in projects, resources must provide estimates of how long it will take to complete the task, which then become their commitments, how much safety time is included. So let's now look into understanding why this belief is actually erroneous. So if you look at a typical task, we might see a distribution like this for how long it would take. And so imagine that you're a person who's responsible for delivering this task, and your performance is being measured based on whether or not you meet your estimates of how long it will take to do the task. Which time will you give? Time A or time B? Of course, you're going to give time B. And look at how much safety is inserted here. It's a huge amount of time, because the distribution has a long tail. There's a low probability that it will be a very long time to do the task, but it is still possible. And when you know that your performance is being measured based on that, then you're going to insert a huge amount of safety in the task. So conclusion is significant safety time is inserted. Actually, significant safety is inserted not only in each task, but usually project managers insert it in the project overall as well. Now the question is, if we're inserting all of this safety time, then do most tasks finish early? Given that probability distribution, we should see them more closer to the A time, and occasionally having some moving between the A and B times. Even if we finish a task early, could the next task begin early? Well, we see in projects that most tasks don't finish early. Why? Because if you finish your task early, then what happens the next time you have to give an estimate for the task on the project? Management is going to expect you to do just as well on that task time, to say, oh, you inserted too much safety in it, we need to cut some of the safety from it. Now let's look more closely at the second question. Even if we finish a task early, could the next task begin early? Well, what we know is in projects there are a series of integration points, meaning where more than one task has to be completed before the next task can be started. So in this case, task B15, and the way the notation we're using here is the number is the time, estimated time to do the task, and the color and letter represent the type of resource needed to do that task. That 5 different tasks have to be completed before we can begin task B15. When can task B15 begin? If the completion of each task relative to the planned start time of task B15 is the following, then when can we begin it? Well, let's see, 5 days late, 2 days early, 10 days late, on time, it's 10 days late. We cannot take advantage of early finishes because delays are always passed on at integration points. So even if we did finish early, we would lose out on taking advantage of those early finishes. And what's the probability of finishing at least one task late? It's not low. So there is a very high chance that there is going to be a late integration task start time, and that it's going to start at the latest, the latest finish of all the tasks that are dependent to it, that must be completed before it. Another problem that we have in tasks, in projects, is what we call student syndrome. Is you have a task that you're supposed to start, how much effort do you put into it relative to when you can start working on it and when it's due? And usually what we see is that there is postponement there, procrastination, delays, that you wait until you get close to the due date to really start working on the task. And then what happens? When does Murphy strike? Murphy's Law, if anything can go wrong, it will. It's right when you're working on the task, trying to finish it close to the due date, so you may actually miss the due date. Another behavior that we have that is causing problems in project environments is called bad multitasking. Now this is a terminology that we use in TOC. It's not multitasking where you're doing 2 or 3 things at the same time, like talking on the phone and doing your email, whatever it is. When we refer to bad multitasking in TOC, we refer to working on one task without finishing it, and stopping working on that task to start working on another task, even though there's nothing preventing you from continuing to work on the first task. And so what happens is the time it takes to do each of the tasks spreads out, like we see here. But actually there's something very significant that's missing here, which is anytime you switch between one task to another, there is a setup and set down time of moving between them, of getting up to speed for where you left off before and getting ready to do the new task. And actually that time is significant, which we'll see later in a little experiment that we do. And that can also lead to quality problems or mistakes because you forgot what you did at one point and make mistakes that you catch later. Whereas if you'd worked from beginning to end on each task, then they would each finish sooner. See here, task A would finish a lot sooner than it does in the second run with the bad multitasking in it. And if you insert all the setup and set down times, then it even further extends. Other resource behaviors that cause problems in projects are, 1, work expands to fill the time due to lack of clear completion criteria, what we refer to as Parkinson's Law. So if you're not sure what it's going to take to successfully finish the task, you keep working on it to try and make it meet successful criteria where you're not even sure what they are, so you keep doing it. Work continues because it must take the full scheduled time to be of high quality, which we refer to as the 3-minute egg rule. So there's no way that an egg can be done before the 3 minutes are up. So they just keep working on it to say, well, it can't be quality if we finished it early. And the final behavior is resources do not typically report early finishes because they would lose negotiating ability for future task time estimates. So what are the conclusions regarding safety time in the plan? Significant safety is inserted into the project plan. We saw there was a huge difference between time A and time B on the task estimate times. And safety is wasted due to different reasons, which we discussed before: impact of integration points, student syndrome, bad multitasking, Parkinson's law, 3-minute egg rule, and unreported early finishes. Another issue that we have to consider is the following. The additive rule is used to determine the project due date. We estimate each time, and we sum the times on the critical path. Critical path was a method for managing projects, PERT and critical path, which looked at the longest sequence of task dependencies to manage the project. But the problem is that the due date is too early if we did not consider resource dependencies, when we need to have a person or a department or a machine being used for 2 different tasks which are scheduled at the same time, or due to the impact of integration points. Then we have made estimates for how long the project will take which are inaccurate. So the definitions is critical path is the longest sequence of task dependencies in terms of time. This is a traditional term and path that is not used in TOC. Ellie came up with a new term called critical chain, which is, I'll give an example of showing how you find a critical chain to better understand what it is and how to identify it. It's the longest sequence of task and resource dependencies in terms of time. So we do need to consider resource dependencies as well when we're planning the project. In other words, the critical chain is the longest sequence of dependencies with explicit consideration of resource availability. So what's the vicious cycle? Resources receive a poor evaluation for missed deadlines, which causes resources to inflate estimates more. The end result is the project still is not complete on time within budget and scope, and promised lead times for future projects are even longer, causing lost work, possibly. So the first thing we're going to do today is we're going to look at what is the solution for an individual project or projects. What do we do for a specific project or a project environment where we don't share resources across projects? And then we'll add additional solution elements when we are in a multi-project environment where we do share resources across projects. We need to have more solution details or injections for that situation. So let's take a look at the process for how you identify the core conflict in a system. So let's take a look at the system being project management. So we would look at what is an undesirable effect. Our project lead times are too long. Our customers have been complaining that our project lead times are too long. Some customers have defected to our competitors as a result of our long lead times. So what's the conflict? In order to satisfy customer and shareholder expectations, time, budget, and scope, we must make reliable promises. In order to make reliable promises, we feel pressure to add significant safety time to each task time estimate. In order to satisfy customer and shareholder expectations, we must contribute to creating a competitive lead time advantage and not create opportunities for wasting time. In order to do that, we also feel pressure to add absolute minimum safety to task time estimates. Obviously, we're in conflict adding significant safety and not adding significant safety, adding the absolute minimum. So there's one conflict. What's another? Critical resources are losing a lot of time moving from one task to another and having to report progress on all the tasks. Background, our resources have to spend a long time getting up to speed on a task that was set aside for a period of time. This time is non-productive time. A significant amount of setup and set down time is affecting resource productivity. So what's the conflict here? In order to satisfy customer and shareholder expectations, we must ensure that progress is made on all tasks. In order to ensure that progress is made on all tasks, we must frequently multitask. In order to satisfy customer and shareholder expectations, we must minimize time lost on setups and progress reporting. In order to do that, we must limit the amount of multitasking. Can't frequently and limit multitasking at the same time. And the final conflict that we look at, we write 3 conflicts, one on each of 3 different undesirable effects, and then merge them into one core conflict, is project ROI and cash flow are frequently jeopardized. Background, we must pay our subcontractors when they start working for us and for materials when we start using them. However, we do not receive payments until progress is made on the project. Therefore, our cash outflows exceed our cash inflows during initial stages of projects. So, in order to satisfy customer and shareholder expectations, we must ensure that we have sufficient safety for each task. In order to ensure we have sufficient safety for each task, we must start work as early as possible. In order to satisfy customer and shareholder expectations, we must postpone spending. In order to postpone spending, we must delay the start of work as late as possible, especially on the subcontractor task. So what is the core conflict? In order to satisfy customer and shareholder expectations, we must complete the project based on the original promises. In order to do that, we must take actions / use rules that will optimize task and resource performance. In order to satisfy customer and shareholder expectations, we must finish projects in minimum time and cost. In order to do that, we must take actions / rules to improve overall project performance. And you can see in parentheses here for each of the actions, D, we show where they come from in terms of the 3 original conflicts with respect to safety, multitasking, and starting work as early as possible. So what is the direction of the solution? It is not to turn estimates for task times completion into commitments. It is to minimize the wasting of safety and to enable early and late finishes to compensate for each other and minimize bad multitasking. And this will be the conflict that you will see in materials that have been presented in TOC, such as the TOC Insights into Project Management. In order to manage projects well, we must meet endangered original commitments. In order to meet endangered original commitments, we feel pressure to compensate for early misestimations, misconsiderations. In order to manage projects well, we must not jeopardize other original commitments. In order to not jeopardize other original commitments, we feel pressure to not compensate for early misestimations, misconsiderations. In TOC, there is a realization that there are 2 types of conflicts, either one of which we can identify to solve, to come up with a solution for the system, in this case project management. So this is what we call a symptomatic core conflict, is because of the core conflict we saw before of how we were planning projects led us into having this conflict of once we started running a project, what do we do once we realize that we're going to miss the due date? We might start using overtime and go over budget in order to bring the due date back in line. So this was actually the conflict that Ellie developed to identify the solution for critical chain project management. Now let's take a look at, that was part of the process for how to improve a system or an organization, was to identify the core conflict and develop the current reality tree and future reality tree based on that. We also need to apply the 5 focusing steps of TOC, or the process of ongoing improvement, identify the system's constraint or constraints, decide how to exploit them, subordinate everything else to the above decision, elevate the system's constraints, and if in the previous steps the constraint has been broken, go back to step 1. Warning, do not allow inertia to cause a system's constraint. So what is the solution for each project? The first thing we need to do is identify the system's constraint. What is the constraint that is most affecting the performance of the projects? It is the critical chain, the longest sequence of task and resource dependencies. And this comes back to an understanding of what is the power of TOC. The power of TOC is based on focus, of focusing on what's most important. So if you compare the project management and production solutions of TOC, you would see that the power of focus is in production, which we covered in the last webinar with more of a description of the 5 focusing steps, was on the bottleneck or the capacity constrained resource, or CCR. That typically there's one resource in the plant that is most affecting its performance. Well, what we've seen in projects is that there may be hundreds, if not thousands, of tasks in a project plan, but actually there's a small number of them which are critical to the performance of the project, which is actually the critical chain. Decide how to exploit the system's constraint. So what do we need to do to make sure that we get the most out of the critical chain? We need to minimize the critical chain time, but protect it strategically with safety. So how are we going to do this? One, we're going to use an early warning mechanism, what we call resource buffers, to ensure that resources working on a critical chain are prepared to start on time or start earlier than the scheduled start date if gains were achieved in upstream tasks on the critical chain. So we get to just have a warning for a resource type that when we get estimates of how soon the task before it is going to finish, that we're warning them to be prepared to start that project task if it's on the critical chain. We're going to use project buffers, which are half the safety removed from the critical chain task, to ensure timely or early completion of the project overall. And we're going to introduce and use measures that reinforce roadrunner and relay race behaviors. So once you get a task, you start it, you start running with it and finish it as soon as possible, like a roadrunner, and also a relay race, meaning you pass it off to the next person as soon as you can. Subordinate everything else to the above decision. We're going to use feeding buffers, which are half the safety time removed, wherever non-critical chain path or tasks feed into a critical chain task to protect the constraint from delays, and schedule non-critical chain tasks to start as late as possible. So we have enough safety to start them. We don't need to spread our resources all over the place. And introduce and use behaviors to reinforce roadrunner and relay race behaviors, eliminate problematic behaviors. And then elevate the system's constraint is we shorten project lead time by adding resources to break resource contention, meaning resource contention is a term we use when identifying the critical chain or working with the critical chain of when a resource has to be doing 2 tasks at the same time, we have to schedule those tasks so that they don't overlap. So let's take a look at an example here. Where tasks are in the same row, that means there's a dependency there. So task Y10 must start and be completed before task G20. And that the arrow going from G20 into B40 means that B40 cannot start until G20 is completed. So you can see the whole dependencies here on the task and the time in which they're scheduled, that this time, if you were using PERT CPM, would say the longest sequence is the middle path, which is 20 plus 20 plus 40 plus 20 is 100. But let's just assume that we have only one of each resource type, then we have a problem here, because actually with PERT CPM we would never finish this project on time if we schedule it to be 100 days or 100 minutes, whatever the time frame is that we're using, because we can't do task B40 and B20 at the same time because it requires the same resource. So what's the first step to identify the critical chain and insert the buffers? We need to cut the times in half. So the times here were estimates with significant safety inserted, so we cut each of them in half. And we're looking at the due date of the project, so we schedule it to end in terms of when it's due. So we've cut all the times in half, and then we focus on resource contention, resolving it, starting from the end of the project plan going backward. So the first resource contention we have is B10, B20, so we move this 2 tasks back so that task B10 would be scheduled to finish right before B20. And now we see we have another resource contention here with the 2 red tasks, so we need to move one of them back in time. So that is the first step, is we've cut the safety times in half, and we have resolved resource contention. The next thing we need to do is identify the critical chain. So the way we do that is we start with the task that is first scheduled, earliest in time, and put it on the critical chain. So that's the first R10 task. Now we're at time 50, and we look to see, in terms of task or resource dependencies, what's the next task that is scheduled earliest in time. So there are 2 dependencies here. There's a dependency between R10 and Y10, because it's on the same line here in terms of the project plan, and there's a dependency between the 2 R10 tasks because they're the same resource. So the earliest one in time is R10. And if you have a choice, let's say there was another task that was scheduled in between those 2, you could pick either one. If they're both starting at the same time and have a dependency to the first task, it doesn't matter which one you pick. Then the next task we pick, next dependency, there's only one, is B10. Then the next dependency is another resource dependency, so B20, and then Y10. So that is the critical chain. It's R10, R10, B10, B20, Y10. The next thing we need to do is insert the buffers. So we removed half the safety time from all the tasks. So now we need to strategically place it in the project plan in order to protect the performance of the project. So the first thing we would do is insert the project buffer. So the critical chain is 10, 10, 10, 20, and 10. So that's 30, 40, 50, 60. And the project buffer is half the safety removed. So the critical chain is 60 here, but remember that we cut those times in half. So that means we took the time of 60 out of it. So now we need to cut that in half, so the project buffer will be 30. Next, we need to insert the feeding buffers. So any place where a task or path feeds into the critical chain, we need to insert a feeding buffer there. So in the top path, we have times, the 2 tasks are times 15. So 15 was taken out of it in terms of safety removed, and cut that in half is a feeding buffer of 7.5. And the Y10 task has a 10 was safety time removed from it. Cut that in half is 5, which gives us a feeding buffer of 5 before the B20 task. So this is actually the project plan now. And so what the feeding buffers do then is they protect the critical chain from delays on the non-critical chain tasks. And if the feeding buffers do happen to run out, we still have the protection of the project buffer for the project. And remember, we have changed the behaviors of the resources, so we've been focusing on making sure that we're more effectively managing the project. And we also want to insert the resource buffers, so anytime there's a handoff from one resource type to another, we have an early warning to the blue resource. When the red resource is getting close to being finished, they're getting estimates of when they think they'll be done to be ready to start their task as soon as possible. Also for the yellow resource, when getting estimates of how much longer the blue resource is going to be working on the project task. So what is the project lead time? It is now 90. It's 25% less than the actual 120 that would have taken if we had done the original plan, and obviously we wouldn't have been able to achieve it without having overlap of the 2 blue tasks. And the project buffer works out in this case, and many cases does, work out to be 1/3 of the project lead time. So this is what the critical chain plan would be here and there's a very high probability that we will finish before the end of the project buffer. So what happened here? What we did was when we took the safety time out, we took the times A and B, we cut it in half, and so this is what ended up happening was we removed most of the safety time from the task, but we still had a high probability of finishing it before it's finishing it within that time. But if it did happen to run late, that's okay, because now we have, with the changed behaviors, we have some tasks completing early. Now, so that's the solution for a single project environment where resources are not shared. What do we need to add to the solution for the multi-project environment? In the multi-project environment, resources are shared across projects. So we use all the solution elements we had before and add some more. So what do we need to add? Well, first we need to understand that there is another erroneous belief that is causing problems beyond the one regarding safety in a multi-project environment. And the erroneous belief is the sooner one releases a project in a multi-project environment, the sooner the project will finish. This is actually not true. This actually leads us to have much more bad multitasking. So let's see what the common complaints are in a multi-project environment. Typically, project managers complain about resources not being available when needed or even when promised. So people or departments or machines not being available when needed to work on their project, have frequent conflicts with resource and resource managers. So the managers of the resource types, like engineers, etc. The due date, quality, scope, and/or budget of projects are frequently compromised. Scope creep frequently occurs, and it is time-consuming to obtain detailed work breakdown structures from resources or resource managers. What are the typical resource complaints? The people who are doing the task on the project. Project priorities are constantly changing. Projects are undertaken without consideration of limited resources. We're stressed out. We have to compromise scope, and there's too much rework. What are the typical resource/department manager complaints? We have frequent conflicts with project managers. We feel pressured to increase staff to handle peak project loads. There's too much rework. It is difficult to know which projects to assign resources to, because they're all important projects, right? And typical executive concerns, the organization is too slow responding to important opportunities. Project lead times are too long. Some projects are abandoned. Project return on investment and cash flow are frequently jeopardized. Too few projects are completed, and the due date, quality, scope, and/or budget of projects are frequently compromised. So what is the core conflict in a multi-project environment? In order to successfully manage all projects in a multi-project environment, we must demonstrate progress on all projects. In order to demonstrate progress on all projects, we must begin new projects without considering available capacity and work on all projects simultaneously. In order to successfully manage all projects in a multi-project environment, we must ensure the success of each project. In order to ensure the success of each project, we must not begin new projects without considering available work and not work on all projects simultaneously. The solution is to release and schedule projects based on global project priorities and available resource capacity. So one of the things that we need to do is we need to look at all the projects that we're doing and prioritize them in terms of importance. And that will determine when we schedule them in sequence of importance. So let's do an experiment now. If you want to, you can do this later or do it now with me, is take out a piece of paper, and we're going to get an understanding of what happens in a multi-project environment or with a person who's doing bad multitasking. So what we have is we have 3 projects. What we're going to do is on the piece of paper, we're going to have 3 columns, and we're going to do this twice. So you have 3 columns on the left, 3 columns on the right, where the first project is going to be writing the numbers 1 through 26. The second project is writing circle, triangle, square in sequence and repeating that. And the third one is going to be, the third column is going to be writing the letters A through Z. So what we're going to do is we're going to do the first run using bad multitasking, is we're trying to do all the projects at the same time. So we work on one. So we write each one. So we write 1, circle A, then 2, triangle B, etc. And we're going to measure the time it takes to start and finish each one of these projects. For the first run, which is using bad multitasking and starting all the projects as soon as possible. So what I'm going to do is I'm going to put a timer on the screen here so that we can start this. So we're starting them all right now, so let's go and see how long this takes. Okay, so I'll give a few more seconds here. I just finished each one of them. I don't know if you noticed. What I noticed was sometimes it was hard to remember which one you were trying to do and what the sequence was on it, and how long it took to do each one. Okay, so now let's start again, and we're going to do each project in sequence. So we'll measure the start and stop of each project and just do the numbers 1 through 26, then the symbols, then the letters, and see how long it takes to do each. Okay, go. Okay, I gave you a little bit more time. Okay, so let's take a look at, here's my times that started, each one started at time 1 and ended at 105, 2, 106, and 3, 107, 1, 18, 2, no, 19, 43, and 44/64. So look at this huge difference here. This is really a great example to show the impact of bad multitasking, is just even moving your hand and then your mind between what you're writing, numbers versus symbols versus letters, how much more time it takes to do each of the projects. That we can finish all 3 projects in 64 seconds or less, depending on what time you came up with in your run of the simulation. That is much more effective, that we can finish more projects with the same resource, more tasks with the same resource or projects, if we get rid of bad multitasking. And imagine when you're thinking about projects or tasks that are much more complicated to do, that how much more time that we can reduce from the task time or the project time if we do that. So this is important to understand, that bad multitasking is a huge waste of time, and it can also lead to quality problems. If you look at what you did on your first run, you may see that sometimes you got a triangle instead of a square, etc., because you got confused about where you last were on that, that you made a mistake when you were doing it. So what are the solution elements that are needed in addition for a multi-project environment? We need to have, to identify the system's constraint, is the company constraint resource, known as the drum or the synchronizer. This could be a more loaded resource or a resource that is used across all or most projects if we do not have a heavily loaded resource. The constraint is either a resource or the ability to complete projects that share resources. Decide how to exploit it. We need to stagger the release of projects based on the drum to finish each in less time. So we stagger them just like we did in the experiment that we just did. We need to prioritize the projects globally based on their impact on throughput, investment, and operating expense, and then prepare a critical change schedule for each project independently. In addition, we need to create the drum schedule based on global project priorities. So we're scheduling based on the most heavily loaded resource, or finding the way to effectively stagger the projects to ensure that we complete them all successfully. Subordinate everything else to the above decision. We need to insert capacity constraint buffers between projects to ensure that the project plan is achievable and to minimize resource contention across projects. And insert drum buffers to ensure that the drum is not starved for work. And elevate the system's constraint. If we need to, we'll increase the capacity of the drum resource. So here's an example. We can see 3 different projects here, which you can have projects running at the same time, like project 2 and 3 are scheduled to be run at the same time, but we stagger them based on the drum resource, which is the red resource, to make sure that we're not trying to overload the resources that we have. And then the CB here is the capacity buffer between each of the drum resources. And the capacity buffer in this case is all the safety time removed from the drum task. So all the safety time removed from the red resource tasks are put in this capacity buffer, because it's very important not to have problems from one project cascade into the other, especially on a critical resource. So then what we want to do is we want to measure the performance of the project using 3 measures. One is, what is the percentage of the critical chain completion, which causes us to focus on the constraint. What is the percentage of the project buffer completed relative to the percentage of the critical chain completed? And what is the rate of consumption of the project buffer? in a given time period is the rate more or less than 1/3 of the interval time. So what are the typical critical chain results? We can see here, for example, Harris Corporation, which later became Fairchild Semiconductor, they finished an 8-inch wafer power fabrication facility in 13 months compared to the typical time frame of 54 months and the pre-planned time frame of 18 months. Then what they also were able to do was reach 90% of the production capacity that was planned 21 days after opening the plant, which is compared to the industry norm of 18 months. By speeding the time to market, payback is twice as fast as planned. Shea Homes, a home builder, was able to reduce the cycle time for developing the land and building a home from 91 days to 56 days, resulting in millions of dollars saved in interest, annual interest costs alone, let alone the increase in throughput, which is even more important. And Pharmacia, a pharmaceutical company, implemented critical chain in project management and clinical supplies, a vital link in the drug development process. The on-time performance increased from 48% to over 90%, while lead times decreased from a range of 8 to 12 weeks to 3 weeks. And the package rate increased from 20 to 50 per month. So that is my introduction to project management, and I'll now open it up to questions. Oh, before I do that, I just want to point out that if you want to learn more about project management, here are the critical resources that I would suggest that you go to. The first is to read the book Critical Chain. That is a novel that Ellie Goldratt wrote to describe the critical chain solution. It does not go into the details of the multi-project environment, but it does have a great explanation about why the critical chain is important and what to do in a single project environment. Another good resource is the TOC Insights into Project Management, which is a flash program that was developed by Ellie and Rami Goldratt to describe the key concepts of the project management, what to change to, and how to cause the change. Another great resource is the project's strategy and tactic tree. It is in the public domain. It's also on the TOC ICO website, which you can access, which is the solutions for how to implement critical chain project management. Not long after this tree was written, Ellie delivered a webcast program on the subject to describe the project's strategy and tactic tree. So that is also available for viewing or purchase as a DVD on the Goldratt Marketing Group website, which is toc-goldratt.com. And that's a great program where you can get an understanding from Ellie about what the content is in the tree and what the solution is for how to implement the critical chain project management solution. And the final thing that I would highly recommend in terms of the list of resources to learn more about critical chain is in the TOC handbook. There are several chapters there on critical chain project management, so you can get into more details of the solution there. And now I will open it up to questions or comments.
Great. Thanks, Lisa. That was absolutely awesome. What a wonderful overview of project management. You can either ask a question by raising your hand, or you can type a question in the question box, or you can type in the chat box. So any questions, please feel free to either raise your hand, type a question in the question area, or you can type a question in the chat box. We'll give a couple minutes for people to be able to input their questions. All right, looks like we have one hand up from Sunil Patdar. Sunil, I'm going to open your microphone. Did you have a question? Your microphone's open. Sunil, did you have a question?
Relating to project management implementation in small-scale industries where the owner is handling all the operations
Yes.
Are you getting me? Yeah. This is relating to small industries where the owner is handling all the operations. It's a single man operation, and a small team is working under him. The owner happens to be
I think we've lost audio on Sunil. Sunil, can you repeat that, please? We seem to have lost audio on you.
one
There he is.
really drop a critical chain of the projects.
I missed part of the question or the explanation because the audio went out for your microphone for a while.
Could you repeat that, Sunil?
Yeah, shall I repeat?
Yes, please.
I'll type in the question.
Okay. All right, excellent. While he is typing in the question, we do have another question that came in from Orlando. So Orlando, let me open up your microphone and you can ask Dr. Ferguson your question. Orlando, your microphone's open.
Good morning. My question is, how do you calculate the capacity buffer in the multi-project environment?
The capacity buffer is all the safety time that was removed from the drum task. So whatever the drum resource is, in the example that I showed in the slides, it was the red resource. Then what we did for the red resource is we cut the times in half. So that means that all the time that was taken out of the red resource task would go into the capacity buffer.
So for any project, I take the whole quantity of working hours of the drum task or resource and cut in half, and that would be the capacity buffer that I place at the end of the of each project. Is it?
Not at the end of the project. It's actually at the end of when the drum resource is being used in the project.
Okay.
But what I recommend is I just wanted to present an understanding of what the solution elements were for the single project and multi-project environments. There is software that enables you to do this. So Realization has a software program, and there are a couple of other organizations that do that. You just have to input the project plan in there, and they would then, the software would actually identify the critical chain, insert all the buffers in the project plan for you.
Okay, thank you very much.
You're welcome.
Okay, other questions that we have. As I said, feel free to raise your hand or go ahead and type it in the chat box. All right, Brian, I see a question coming in from Brian Jackson. Brian, we're going to go ahead and open up your microphone. Brian, go ahead. Oh, he says he's got no mic. So, Lisa, I'll read this for you. He says, I'm not completely clear on what the drum buffer is. Can Lisa review that again?
Okay, the drum buffer is to ensure that the drum is not starved for work. So what it is it's a protection to make sure that the drum, basically what we're doing is we're making sure that the drum always has work to do. So we're putting protection in the plan to ensure that the drum is never starved for work.
And with that, he says, thank you.
You're welcome.
Any other questions that we have? I don't see any more questions coming in, Lisa. I wanted to thank you again for an absolutely wonderful webinar. And as always, all the webinars are recorded and they are put back up on the TOC-ICO website. It is part of your member benefits that you can access all the host of webinars that we have recorded in the past. I think you'll find that there is an incredible array of amazing thinkers that have so graciously share their time like Dr. Ferguson has today. So with that, we'll sign off. And Lisa, thank you again.
Thank you, Carol.